Hello and welcome to the second part of the tutorial for the Student IoT Kit. My name is Miloš Viktorović and I am the teacher of the ICT module of the Smart Urban Environments course. And as a part of this module, you already know that there is an assignment. Assignment is done on the Student IoT Kit, which is based on Raspberry Pi and Group Pi Plus. And for this, I have created two-part tutorial on how to assemble the kit, and in this part we'll be dealing with how to connect to the kit, how to actually access the desktop environment of the Raspberry Pi, and how to write the code in Raspberry Pi so that you can collect data from the sensors as it is required for the assignment of the ICT module of Smart Urban Environments course. So without any further ado, let us start. First thing that we need to do, and I would strongly advise you, is to go through the Student IoT Kit manual on Canvas and read it in details. There you have all the steps necessary explained. And already in the first part of the tutorial, I have covered some of the steps, primarily with connecting the hardware components of the Student IoT Kit. And now I'm gonna explain you how to connect to the desktop environment of Raspbian OS and how to actually access the development environment of the Raspberry Pi. Here you'll see the steps defined in details, and I'll go through these steps and show you practically how you can achieve this. So the first thing we need is our control panel in the network and internet part. We can go to the network and sharing center. This is all done on Windows 10. So you can find more information about how to do these things on Mac or Linux inside the links in this document. So let's go back. Here we see the networks I'm already connected, and what we are interested in is change adapter settings panel. This gives us all network connections that we have in this moment at the computer, active or not active. As you can see here, I have my Wi-Fi, I have my Ethernet connection, I have various other connections, some virtual, some real. But what is the most interesting for me is the connection that will be created the moment I plug the Logilink USB to Ethernet adapter into the one of USB ports on my laptop. So at this moment my Raspberry Pi setup is still not powered. I just need the white adapter that you have in your Student IoT Kit, and I'm gonna plug the USB of that adapter into my laptop, and you'll see what happens in a few seconds. As you can see here, the new Ethernet connection appeared, named Ethernet 9 on my laptop. On yours might be differently, but this is the latest one that appeared, and it appears few seconds after you plug in the adapter. When you do it for the first time, it might take a few seconds more. You might also get messages that new drivers are installing, etc., but the same thing will happen. So if you go back to the manual, you'll see the step 4. We already covered the steps until the step 4 in the first part of the tutorial. Step 4 is explaining how to create a local network with your Raspberry Pi, between your Raspberry Pi and your laptop, and how to also define parameters of that network so that you, within your subnet, you can access the Raspberry Pi. More details on local area networks and subnetworks you can find on Wikipedia. There is a lot of other materials online. I would advise you, if you have time, to read through this to understand what is happening in the background. Although this is quite a complex topic, at least basic understanding I think would be beneficial. So next step that we are going to do is we are going to connect, uh, set up parameters for this connection based on the information given in this manual. What is very important is that if you're creating this subnet with these specific parameters, they are static parameters. So in case you have a network connection that is already using similar subnet, you might encounter problems. Therefore, my advice is to disable all the other network connections that you have. So for example, your Wi-Fi on the laptop. You can simply do that by pressing the disable button. Later you can enable it with the same button. I'll show you on my Ethernet connection. And enabling is as simple as pressing enable again. So by disabling all other connections, you make sure that no other conflicts will appear. Be advised that if you disable your Wi-Fi connection or your internet connection, you might lose internet access. But in order to avoid this kind of problems, I would suggest that if you are not sure whether you'll have a conflict, that you disable it temporarily while you work with Raspberry Pi. I have already checked before, so on my laptop there won't be conflicts. So I'll leave my connections enabled, and I'll go into the properties of this specific connection that I'll use for access to my Raspberry Pi. Here you can see a lot of protocols, a lot of connection items. For us, what is the most interesting is the Internet Protocol version 4, TCP version 4. We want to change those parameters. And we'll go into properties. Here you can see that you can change multiple things. By default, they're set to be obtained automatically. But as we do not have a DHCP server established, this will not be possible. So therefore, we need to use the specific IP address. Which parameters you need to type in, you can see in the manual. So it's 192.168.1.121. You'll see that I automatically got also the subnet mask field. So this happens automatically, but just in case you also have information here. For now, you can skip the default gateway and DNS server settings, as also without them the connection will work. You might get some messages like this. This is due to the fact that I've used multiple adapters to connect to multiple Raspberry Pis, so they have similar setup. But in this case, I know that they're currently disabled, so I will click no. You won't probably get this message at all. Okay, so now we have this connection set up, but as you can see here, it's still not connected because Raspberry Pi is not powered up and the Ethernet cable is not connected to the adapter. So what I'll do next is I will power up the Raspberry Pi. I'm just gonna plug it in directly into the power bank and start the power bank. Now it's booting, and you already see that something is happening with the connection. This might take again a few seconds up to a few minutes, especially the first time when you start it. But if you connected everything correctly, your OLED display on your Raspberry Pi should start up. Also, you will see the LEDs blinking around the Ethernet cable, and soon enough, when the connection is established, actually you'll see the information on the OLED display showing the IP address. So as you can see here, that's the step 5. So if you see the address showing on the OLED display, that means that connection has been established. We can also validate this If you go to the status of the connection, you see obviously there's no internet access, but if you go into details, you see that this is the address you set up, so that is correct. On your Raspberry Pi it will be shown different numbers, but within the same subnet. If you want to know more about that, I recommend researching subnetworks, and then you'll have clear idea what is happening in the background. But for this tutorial, we do not have enough time to go through that. For the next step in the kit, you'll need VNC Viewer installed on your laptop. You can find it here. So it's real VNC, and then you find the VNC Viewer, or just Google it. You install it on your platform. I already have it installed, so I'm gonna run it, and we have it here. So next step is very simple actually. You need to type in here the address that you see on the screen of your Raspberry Pi. In this case, and it should be in your case as well, is 192.168.1.123. Now it's as simple as clicking enter, and the VNC connects. You'll see here that you need to enter username and password, and you'll also see the catchphrase. This is a catchphrase defined by default. Once you access the Raspberry Pis, you'll be able to see the same catchphrase. So the idea is that both devices have the same catchphrase, so that you can identify which ones are you connecting to. If you go back to the manual, you'll see the username and the password. So username is Pi, password is IoT, and username and password are case sensitive, so be aware of that. Click OK, and you have a window which gives you access to the desktop environment of Raspbian and actually your Raspberry Pi. So now, once we have this window open, you can see the desktop of the Raspberry Pi. Actually, this is Raspberry Pi Raspbian OS desktop environment. You'll see that it reminds you of Windows environment. You also have some sort of a start menu. Here on each startup, you see the window of the script that automatically starts, and this script initializes the chip on the Groove Pi Plus, and also initializes the display so it can print out the message about the IP address. So as you can see here, the message: do not terminate this script and window, therefore do not close this window, just you can put it down the taskbar. Here you have a couple of basic things. I already created a couple of scripts that are running, so base scripts is something that you should not change, as they're the ones running in the background, enabling all the connections, display and everything. So assignment is the folder where you will put all your assignment code in one place, and examples is a folder where I gave you already a couple of pre-prepared examples that you can run and test. Here what you also see is Tony Python IDE. So this is the program you will use to write your Python code. As you can see here, it already has opened the humidity example. We're going to close that for now. So you can write your code from scratch simply by pressing new, and then you just type Python code, something like simple as hello world, and then you run code simply by pressing run current script. Of course, before that you need to save it. You will save it in the assignment folder. So let's save it under new name hello world 1. Okay, and you see it's not hello, it's hello. Sorry, my mistake. You can rerun it. Now it's hello world. And this is basically the environment you can use to write your code. Examples of the code, as I already said, you can see in the examples. So this is one of them. This one will read the temperature from the digital temperature and humidity sensor connected to the port D2. So I already have the sensor connected to port D2, as you can see here in the information. So we can try to read the information from it. And you see, current temperature in my room is 20 degrees and current humidity is 51%, which corresponds to the reading I have on my digital thermometer as well. So it is as simple as that. You can stop the code at any time, pressing stop. And you can see here the example of the code. This is absolutely complete code for reading from this digital sensor. And this is the main function. You can see all of this in documentation. I also gave the examples of that in Git environment, so it will be easy to access. One more thing that I want to stress out, and it is very important, is the connectivity to internet. And as you can see, it can be done very simple, like on any other device. You open and you have all the Wi-Fi's that are in the vicinity. Now I will try to connect to my home Wi-Fi, and as you can see, it automatically connected because I used this Wi-Fi before. But it is as simple as connecting on to Wi-Fi on your Windows PC. You just choose the Wi-Fi here. It will ask you for the password. You click OK, and then the connection is established. A simple way to check the connection is to open the browser and go to any of the web pages. Here I have bookmarked a couple of them that might be interesting for you. So this is where you can find all the documentation regarding GroovePy and all the sensors. This is the web page of TUE GitLab, where you can find all the example codes. You'll have to log in with your username and password. In case this doesn't work, I will also provide the backup link for all of these codes. So it is important that you check that your connection works, and this is the simplest way, because one of the tasks in the assignment is to establish the MQTT connection, and MQTT requires active internet connection, so you have to be connected to the internet, and your internet has to be working on your Raspberry Pi in order to be able to transmit the data using MQTT. So in order to demonstrate this, we can go up again to the examples, and we have MQTT example of how you can stream the data from the rotary sensor. So here, this is quite a complex code, but most of this code you can directly reuse. So you can see here there are a couple of things you have to set up. Your client ID, which MQTT host you will use, at which port. You have all of this information in the manual that I showed before. So I will be streaming to this topic, and then there are certain things you have to do before you even start streaming. You have to define what happens in case message arrives, what happens once you subscribe, what happens once you unsubscribe, or when you connect and disconnect. So all of these things you define in advance as the actions that will happen in case of one of these things happens in the connection. Then you try to connect, I won't explain this code in much more details because there is explanation on the Git page that I already showed. What is important here is that I will connect the analog sensor, rotary analog sensor, to port A0 as I already done, and I'll just start the code. You'll see here the debug messages. One of them is MQTT connected. So current potentiometer value is 160.2. I will rotate it a bit and you'll see now different values. Idea of this code is to show you how you can send the information, and in order to validate that this works, we need to use the broker. So I will stop the code for a second. I know that at this topic I will be receiving, and on topic of test topic client ID angle I will be receiving messages. So in order to test all of this, I need to go back to my laptop. There I have already opened the client that connects to same broker. So you need to make sure that you're connected to the same broker. So broker.hivemq.com. Client ID is not important as long as it's unique. So you can press connect. You get connected. So now I want to subscribe to the topic. And I know that this is a test topic. Angle. And I will subscribe with red color. So now I'm subscribed to the topic. If I go back to my Raspberry Pi, it's not sending anything because, as you can see in this information, it will only publish the change that is bigger than 5 degrees. So I actually need to move the potentiometer, and you see we get 160. I'm still moving it. It's 97, and so on. So this is how you can test that your MQTT connection works. Now we can go back to our Raspberry Pi. I'll stop this code and I will completely close the Pi. So here you have a start menu, as I already mentioned, with a lot of tools and software you can use for programming, for educational purposes, internet, office, etc, etc. So you can use all the tools on this Raspberry Pi, but the most interesting one for you will be Python IDE, in which you will write your codes. And of course you have the examples folder. You use the examples provided here, but also provided on the GitLab web page. So you can use all of those codes, combine them, take parts of them, etc, etc, in order to finish your assignment. That would be it for this tutorial. I hope you have enough information to continue working on this assignment, and if you have any questions you can contact me through Canvas. Good luck and enjoy your assignment.